experiment 4, soup 1. This is the coding part. We include wire, LCD, and liquid crystal I2C for the library of liquid crystal with I2C because my LCD uses an I2C. And for the initialization of pin declaration, I use pin 1 as 8, pin 2 9, and delay is 200, and the declaration of button state 1 and button state 2. So yeah, first from this line, LCD set backlight pin 3. It will just set up the LCD as high and to light up the LCD, and as input of backlight high, pin mode pin 1 input, pin 2 input, and LCD begin 16:2 because it uses a 16:2 LCD, and clear to clear up the whole thing in the LCD. And for the main code, void loop, if button state 1 is equals high, it will indicate switch 1 is clicked, and if button state 2 is high, it will indicate switch 2 is clicked, and if both are low, it will just indicate ready to click. So now we have uploaded and see what happened. And says ready to click, and if I click switch 1 high, switch 1 is clicked, and if low again, says ready to click, and if switch 2 is high, it will indicate switch 2 is clicked. Okay, stop. This is the code. So what will happen is that if I input a number of loop in the serial monitor, it must display in the LCD, and the transition of the LED must go and do what I inputted in the serial monitor. So here it go. So for my starting code, I use the library of liquid crystal I2C, and for my initialization, x is equals to 0, declaration, and delay is equals to 150, LED 1 is equals to pin 11, LED 2 is equals to pin 12, LED 3 is equals to pin 13. So for the setup, LCD begin 16:2 to set up my LCD screen, and serial begin 9600 for the serial monitor, and LCD set backlight high to light up my LCD. So for the pin mode, LED 1, LED 2, LED 3 is the output, and for the serial print, for final coding, serial print entered loop, it will print on the serial monitor. Then LCD set cursor to 30, and LCD print number of loop. It will indicate in the LCD, and the cursor is 7:1. It means the value is inputted below the number of loop word. And so while serial available is equals 0, meaning it will start at 0, the available number is 0, and x is equals to serial dot parse int. It means that the number or word that I will input the serial monitor is that it will just be represented as a number, and it will be an integer. So serial print x, for that is the declaration. Serial print x, and serial print /n means that the print must be spaced after the print x. So LCD print x. For the loop, for int loop 1 is equals to 1, loop 1 is less than or equal to x, loop plus plus. For int I is equals to 11, I is equals to less than or equal to 13, I plus plus. This means that the first loop is for the loop. Is for the first for loop is the loop of the sequence. And for the second for loop, it means that the light must go must increment and turn off. Then the for the backward of the transition of the LED, it must decrement and turn off function, thus the LED must be low. And here we go at the code, and we will try and upload it. I will input a number here, says entered loop. Let's say I input number 16. And it go 16 loops. And try again at 5 loops. For the implementation, I'd like to present you, I'll just input 16. 16. 16 loops. And 16. And for another one for testing, 8. Try 8 loops. 3, 4, 5, 6, 7, 8. 8. Okay. And here we go. If I inputted, the problem in SUP3 is that if I input a number in serial monitor, it must display in the LCD, BCD counting, and it must show in the LED display. So for that, I use this code. I use the library of liquid crystal with I2C and the pin declaration of X is equals to 0, delay is equals to 500, LED 1 is equals to 11, LED 2 is equals to 12, LED 3 is equals to 13. For the setup, LCD begin 16.2 for the LCD and serial begin 9600 for the serial monitor. And for the inputs, LCD set backlight pin 3 positive, set backlight high, LED 1, LED 2, LED 3 output. And for the turn off function, I use the LED 1, LED 2, LED 3 low. It must show turn off. So the loop, here we go. The display in serial monitor must be magbilang ng, and for the LCD, set cursor to 0. LCD print counts 1, 2. It must print in the LCD and the set cursor is 0, 1. While serial available is equals to 0, it will continue, and X is equals to serial parse int, meaning if I input a value, any value, it will print X as X. So serial print X, and serial print /n, meaning the space, and LCD print X, it prints in the LCD. So if X is greater than 7, the serial print in the monitor will show NA, then turn off, then LCD print NA. It will show in the LCD. And else, for the for loop, loop is equal to 0, then loop is less than or equal to X. X means in the previous case, the parse int. So LCD clear, set cursor 30, LCD print BCD, LCD set cursor 0 to 1, LCD print loop, then turn off. It will just show the loop and show the counting in the LCD. So if loop is equals to 1, the LED 1 is high. Else if loop is equals to 2, LED 2 is high. Else if loop is equals 3, LED 1 and LED 2 is high. Else if loop is equals 4, LED 3 is high. Then so on and so forth. Then if continue to loop number 7. then turn off again after some time. So for the experiment and the actual footage, here it goes. So for example, I input a 6, it will count 1 to 6, then turn off. Another one, if I input number 7, 1, 2, 3, 4, 5, 6, 7. If I inputted a number larger than 7, it will show this way. Example 8. 8 is not applicable, so it will not count. That's it. Thank you. So for the final supplement, experiment for support. Here's my code. First, include the library of the I2C LCD. And for the pin declaration, variable declaration, I used initialize P is equals 0, switch 1 is equals to 8, delay is equals to 250, LED 1 is equals to 11, LED 2 is equals to 12, LED 3 is equals to 13. Then bottle state 1 is equals to 0, bottle state 2 is equals to 0. Then my switch 2 is equals to pin number 9. For the setup, LCD begin. For the LCD, 16 and 2. Set backlight, pin 3 positive. And LCD set backlight high to light up my LCD. Then LCD print nagbibilang. It will print nagbibilang word on the LCD screen. Then pin declaration, switch 1, switch 2 are both input, LED 1, LED 2, LED 3 are output. Then for the coding system, button state is equals to digital read switch 1, meaning it will digital read button state 1 as switch 1. Then set cursor 00, LCD print press switch 1, LCD set cursor 01, and it will LCD print press switch 2. So if button state 1 is equals high, LCD clear, LCD set cursor 00, LCD print number of loops. It will print number of loops on the LCD screen. Then after all the coding, it will clear again the LCD screen. Then so be it. Then P++, meaning the increment. LCD set cursor 12.0, LCD print P, delay is equals to 500. Button state 2 is equals to digital reads switch 2. If button state 2 is equals high, LCD set clear, set cursor 00, LCD print hello world, set cursor 31, LCD print loops. Then for int loop is equals 1, then loop is must be less than or equals to P. Then it will proceed loop plus plus, that increment. Set cursor 01, LCD print loop. Then for int I is equals to 11, I must be less than or equal to 13 to showcase the loop that must be presented in the switch 1. Then digital write I high, delay digital write I low. It will just show the process of changing the transition of the LEDs. Then after some time, the position must return to 0. Then it is the actual code. And let's see the code running. Let's upload. So press switch 1. This is my switch 1. Switch 1 is high. It will count the number of loops. You can see. And stop in number 16. Okay, that's 16 loops. Then if I press switch 2, it will follow the number of loops in switch 1, just like that, with the hello world. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then it will just return to 0. And for faster transition, you can change the delay for a lower speed. In this sample, I use 500 delay to show the actual transition of the LED. And that's all. Thank you.